Now we are going to see the what are the effects will be happen in slip on rotor parameters. Okay, effect on rotor parameters. Okay. The first parameter will be, there are 5 parameters are there. The first parameter is rotor frequency. Second parameter, magnitude of rotor induced EMF. Okay, magnitude of rotor induced EMF. Third parameter, rotor reactance. Fourth one, rotor power factor. Fifth one, rotor current. Okay, so these are the 5 parameters which we are going to discuss in this lecture. Okay, in this lecture. Okay, now we will see step by step. Okay, what are the parameters are there? We will see step by step. The first parameter is rotor frequency. Okay, normally before going to the rotor frequency, we are going to set the notations. Okay, notations. So when you give the supply to the stator, the rotor will be starts running it. Okay, before starts running it, it will be at standstill. Okay, the condition is at standstill. Standstill means you are giving the supply but the rotor not running. Okay, it will be in a starting position. Okay, that is the meaning of standstill. Okay, the rotor not running it. Okay, the rotor not running it. So at standstill condition, the rotor current, okay, the frequency of rotor current, the frequency of rotor current is same as that of supply frequency. Okay, as that of supply frequency, that is NS equal to 120 Fs by P. Okay, this is equation 1. Okay, equation 1. Okay, the second case, at running condition. Okay, first one is at standstill, second one is at running condition. At running condition, what happened? The frequency of rotor current is same as that of slip speed. Okay, as that of slip speed. Slip speed means the frequency of rotor current, that is the notation is NR. Okay, the notation is NR. NR equal to, okay, 120 Fr by P. Okay, 120 Fr by P. Now here it will be a slip speed. Okay, slip speed means the frequency of rotor current is same as that of supply frequency. So what we are going to do here, slip speed means ns minus nr. We know that slip s equal to ns minus nr by ns. So from that s into ns equal to ns minus nr. This s into ns minus nr is nothing but slip speed. Okay, slip speed. So slip speed is directly proportional to the frequency of rotor current during running condition. Okay, during running condition. Next, now divide equation number 2 by equation number 1. We get equation 2, what it is? ns minus nr equal to 120 fr by p. Okay, this will be divided by equation number 1. What is your equation number 1? N, yes, here 120 fs by p. Okay, so here p and p will be cancelled, 120 will be cancelled, and this ns minus nr by ns, what you have to re-express? S equal to fr by fs. Therefore fr equal to s into fs. Okay, so this is the formula for frequency of rotor current. Fr equal to s into fs. Okay, Fr equal to s into fs. Any doubt? You have any doubts? You have any doubts? Anyone? Anyone? Okay. Anirudh, you have
No doubt, sir.
okay. Second one is magnitude of rotor induced EMF. Okay, magnitude of rotor induced EMF. Same condition. Okay, same condition here also. The magnitude of rotor induced EMF, the condition same. At rotor in standstill. Okay, rotor in standstill. The synchronous speed ns is directly proportional. Ns is directly proportional to synchronous speed is directly proportional to rotor induced EMF. Okay, the EMF notation is E and 2 stands for rotor. Okay, stator means, note down, stator means we have to express EMF E1, resistance R1, reactance X1. Okay, reactance X1. In terms of rotor, we have to express E2, resistance R2, resistance X2, and the speed will be nr. Here the speed is ns, speed will be nr. Okay, so these are the notations we are using. So at stator, the notations we have to express in terms of 1. In rotor, we have to express in terms of 2. Okay, 2 stands for rotor, 1 stands for stator. So the synchronous speed is directly proportional to E2. Synchronous speed is directly proportional to E2. Okay, another one, same. At rotor, in running condition. Okay, so when the rotor, it will be in running condition, the notation will be E2. Okay, E2 stands for rotor, but it will be in running, so E2R. Okay, E2R. This suffix R stands for running. Okay, R stands for running. So E2R is directly proportional to same slip speed, ns minus nr. Ns minus nr. Okay, this is equation number 1 and this is equation number 2. Same, we have to divide equation number 2 by equation number 1. We will get ns minus nr divided by ns equal to E2R by E2. Okay, E2R by E2. So ns minus nr, sorry, ns minus nr by ns equal to E2R by E2. So ns minus nr by ns we know slip, s equal to E2R by E2. Therefore E2R equal to S into E2. Okay, S into E2. Okay, this is my second. First we have discussed frequency of rotor current. Second one is rotor induced EMF, that is magnitude of rotor induced EMF. The notation is E2. And third one is we are going to see rotor resistance and reactance. Okay, reactance. Okay, same. At rotor standstill, we have to set the notations. R2 is the rotor resistance per phase at standstill. Next one is X2. X2 will be the rotor reactance per phase at standstill. Okay, rotor reactance per phase at standstill. And FR is the rotor frequency at standstill. Okay, at standstill. Now we know the basic formula for reactance. we know that reactance will be X equal to omega L. Okay, X equal to omega L. X stands for reactance, omega is the angular rotational speed. Okay, omega equal to 2 pi F into L. F is nothing but frequency. Now we are talking about rotor reactance. So X2 equal to 2 pi, X2 equal to omega into L2. Okay, omega into L2, where omega equal to 2 pi F R into L2. Omega R into L2. R stands for rotor. 2 stands for also rotor. X2 equal to 2 pi F. We know that omega equal to 2 pi F. Okay, 2 pi Fr. Now 2 pi into Fr. How much value Fr we know? Fr equal to, we already calculated, S into Fs. S into Fs into L2. We know that Fr equal to S into Fs. Okay, so this is X2. Okay, X2 equal to 2 pi S into Fs into L2. Okay, in the same way, we are going to do it for at rotor in running condition. Running condition. Okay, this is, you can take this is equation number 1. Okay, at running condition, what is the notation? R to R. Okay, R to R stands for R2 rotor resistance per phase during running condition. X2R is the rotor reactance per phase running. So X2R equal to, in the same way, omega into L2. Omega into L2, where omega equal to 2 pi Fr. Okay, 2 pi Fr equal to 2 pi Fr into L2 X2R. Therefore X2R equal to 2 pi S into Fs into L2. S into Fs into L2. Okay, S into Fs into L2. This is my this you can take 2 pi S into Fs into L2. So you can take S outside, 2 pi Fs into L2. So S into this 2 pi Fs into L2 means it will be in running condition. Sorry, it will be a standstill condition. So here in the above, we know that it will be, this condition is for standstill. Standstill, what is the condition during standstill slip value? S equal to 1. So what we have to do? We have to, instead of S, you have to substitute. Okay, you have to substitute. How to substitute 1. Okay, you have to substitute 1 here. Yes, you will get it. So again 2 pi into Fs into L2, which is equal to x2. Okay, so this is my equation number 1. Okay, at standstill s equal to 1. Okay, please substitute it. So this s into x2, this 2 pi Fs into L2, we have take it from equation number 1. So s into x2 r. Okay, this is x2r equal to s into x2. And fourth one is rotor. In terms of impedance we have tried here. In reactance we have tried the impedance. So the impedance formula at standstill rotor. Okay, rotor at standstill, the impedance notation is Z equal to square root of R plus square root of R plus Z equal to R plus J X. It is ohm per phase. So in terms of notation rotor, x2 equal to r2 plus j into x2. So in terms of equation, z2 equal to, if you take the real and imaginary, you will get r2 square plus x2 square. The unit is ohm per phase. Okay, ohm per phase. Next, at rotor running, Z to R equal to same, R to R plus J X to R. Normally the resistance value in stator and rotor is same. Okay, as well as during the running condition, okay, and the starting condition of the rotor, the resistance value is also be same. Okay, the resistance value, note down the resistance value in rotor during standstill and running condition is same, that is R2 equal to R to R. So what we have writing, Z to R equal to, instead of R to R you can put same, R2 plus J X to R. If you take the conjugate terms, you will get Z to R equal to square root of R2 square plus X to R square. R2 square plus X to R square. Okay, that is magnitude. Okay, so if you find out the magnitude, you will get the square root. Okay, this is the magnitude of impedance. Magnitude of impedance. Okay, next, fourth one, rotor power factor. Okay, rotor power factor. So rotor power factor, okay, we know the notation of power factor. What is power factor? Which is cos phi. Okay, this is the power factor cos phi, okay, which is equal to 1. Okay, cos phi equal to 1. Now by using this impedance, resistance and reactance, we are going to calculate the power factor. So before going to the calculation of power factor, we have to draw an impedance triangle. Impedance triangle. So how to draw the impedance triangle? Okay, this adjacent will be R2 and the opposite will be X2 and the hypothesis will be Z2. The angle will be phi. Okay, angle will be phi 2. Okay, angle will be phi 2. So phi 2 means same type. Here also we are going to write rotor at standstill. The power factor will be cos phi 2. What is cos phi? Cos phi will be adjacent divided by hypothesis. Adjacent will be, this is adjacent, R2. Hypothesis will be this one. Okay, Z2. Okay, R2 by Z2. So therefore cos phi 2 equal to R2 by what is the magnitude of impedance at a standstill condition? Square root of R2 square plus X2 square. R2 square plus X2 square. In the same manner, we are going to find the power factor at rotor during running. What is the running condition? Same, cos phi 2R. Okay, cos phi 2R equal to, so again we have to draw the impedance triangle. Okay, impedance triangle we have to draw. How to draw the impedance triangle? The bottom is R2 and this is Z2R, this is X2R. The angle is phi 2R. So cos phi 2R equal to same, adjacent by hypothesis. Adjacent will be, because since the rotor value in starting that is standstill and the running condition in rotor is same. Okay, the rotor resistance value during starting and the running condition will be same. So R2 by Z2R. Therefore cos phi 2R equal to R2 by square root of R2 square plus X2R square, which is equal to cos phi 2R, which is equal to R2 by square root of R2 square plus what is the impedance value of rotor in running condition? We already calculated. X2R equal to S into X2. Substitute it. S into X2 whole square. Okay? You understand my point? Okay. Next. Fifth one, rotor current. The rotor current notation which we are using I2, because I1 stands for stator. Okay, I1 stands for stator, I2 stands for rotor. So same at rotor during standstill. Okay, rotor during standstill. The current formula, basic current equation, current I equal to ratio of EMF divided by impedance. Okay, because basic equation we already studied in your basic electrical engineering. Z equal to V by I or Z equal to EMF E by I. Okay, this is the basic equation. By using this equation only we are writing I equal to E by Z. Okay, EMF, E stands for EMF. So here at standstill means I2. I2 equal to E2 by Z2. So E2 divided by Z2. What is the Z2 equation? Anyone? Anirudh? Anyone? Register number 5. Register number 5. Who is register number 5? If I mention the register number, you have to give the answer. Otherwise, I won't give the attendance. Register number 5. Register number 6. Register number 10. 10. Register number 55. Register number 10.
Root R2 square plus X2 square.
What's the register number?
10.
10. Okay. Z2, what is the value, ma? R2
Root
square.
R2 square
Plus X2.
X2.
Okay. Good.
X2.
Okay. Good. Thank you. Okay. Same case. At rotor during running condition. What is the notation? Rotor during running condition, I2R. I2R equal to E2R divided by Z2R, which is equal to register number 56. Register number 56. 56. Anirudh? Anirudh? Bharat? Bharat is there? E2R equal to S into E2 divided by square root of R2 square plus S into X2 square. Okay, X into X2 square. Okay, S into X2 square. Okay, so these are the 5 parameters which we are discussing in the today class. Okay, discussed in the today class. The first parameter will be, what is the first parameter? First parameter will be the rotor frequency. The second parameter will be the magnitude of rotor induced EMF. The third parameter will be the rotor reactance. Fourth parameter will be the rotor power factor. Fifth one is rotor current. Okay, the first parameter will be rotor frequency. Fr equal to S into Fs. And the second parameter will be magnitude of rotor induced EMF, that is E2R. Third parameter will be the rotor reactance, X2R. And fourth parameter will be rotor power factor, cos phi 2R. Fifth parameter is what is the fifth parameter? Rotor current, I2R. Okay, now in next class I will explain how to solve the problem by using this 5 parameter. Okay, this is one 20 mark question. Okay, it will be a big question. So in your examination you have to write derive an expression of slip parameters in rotor of 3-phase induction machine. Means immediately you have to write all this 5 expression. The first one is rotor frequency, second one is magnitude of rotor induced EMF, third one is rotor reactance, fourth one is rotor power factor, fifth one will be the rotor current. Okay, fifth one will be the rotor